In Chapter 5, we focus mostly on polynomial functions. In Chapter 6, we're going to focus on rational functions. Rational functions are made up of polynomials, one on the numerator and one on the denominator, both of the same variable. When you're asked to find the domain of a rational expression or a rational function, you want to remember that you're dealing with a fraction. So what do you know about fractions? You can have any value on their numerator, but the denominator is not allowed to equal 0, or the function will be undefined. So you want to figure out all the values that make the function undefined or indeterminate, and you want to remove those from the domain. For the first problem, the denominator is x minus 2. The denominator can be any number except 0. So x minus 2 is not allowed to equal 0. If you add 2 to both sides, x is not allowed to equal 2. You can sketch this on a graph, on a number line. It can be bigger than 2 or smaller than 2. It just cannot equal 2. So it would go from negative infinity to 2. Open parenthesis, which shows that you can get infinitely close to 2 without quite reaching it. Union 2 to infinity. This would be your domain in interval notation. For part B, you're trying to figure out all of the values that would cause your denominator to equal 0, and you want to remove them. So if you solve this by factoring, you would get x minus 4 times x plus 4 is not allowed to equal 0. So you can say x minus 4 is not allowed to equal 0, and x plus 4 is not allowed to equal 0. So x is not allowed to equal 4 or negative 4. And then you want to write that in interval notation. Some students graph this to make the interval notation easier. So it would go from negative infinity to negative 4, union negative 4 to 4, union 4 to infinity. So this would be your domain in interval notation. See if you can pause the video and try part C on your own. All right. So we need to figure out what values would make x squared minus x minus 6 equal 0, and we want to remove them. So I'm going to solve this similar to part B, so I'm going to factor. First times first equals first, last times last equals last. I'm going to try 3 and 2. I want the 3 to be negative. I'm going to try the 2 to be positive. X squared, negative 6. Negative 3x plus 2x is negative x. So this is factored. We guessed and checked to make sure it was right. So we can see that x is not allowed to equal negative 2 or 3. You can sketch it on a number line to make it a little bit easier to see. And then write your final answer in interval notation. When you're ready, check your final answer with mine, and then we're going to try part D. We want to figure out all the values that would make our denominator equal 0, and then we want to remove them. So x squared minus 16 is not allowed to equal 0. So if we solve this using the square root method, we want to isolate the quantity squared. So we're going to subtract 16 from both sides. So x squared is not allowed to equal negative 16. So what number squared does actually equal negative 16? I was thinking 4 times 4 is positive 16, so that's not it. So let me try negative 4. Negative 4 times negative 4, that also equals positive 16. There is no real number where you can square it or multiply it by itself and be left with a negative value. So there's actually no solution here when you take the square root of both sides, which implies that there's no value that would make your denominator equal 0. So that means x could be any number at once. So it would be from negative infinity to positive infinity. There is no value that you could substitute in for x and make your denominator equal 0. The smallest your denominator will ever actually be is 16, right, when x is equal to 0. 0 squared plus 16. Any other number here, your denominator will be bigger than 16 because it's a quantity squared. You'll notice that for the first example up here, that if you were to plug a 2 in for your denominator, you would get, and for your x, you would get 2 minus 2, which is 0, so you get 4 over 0. So if you plugged in a 2, that would cause a problem. So you want to make sure you remove those problem areas from your domain. When you're simplifying rational expressions, you want to kind of treat it like simplifying a regular rational number. So for example, if I had 10 over 20, I could break that up into 10 times 1 over 10 times 2. And I noticed that 10 is a factor of the numerator and denominator, so I could divide the numerator by 10 and divide the denominator by 10 to reduce my fraction or to simplify my fraction. I'm going to use that same property here. This property holds true as long as w does not equal 0. So you want to take a look at the first example here. It has to be a factor of the numerator and denominator for this property to work. When I say factor, I mean put together by multiplication. So I'm going to go ahead and try to factor this numerator first. I'm going to factor out a GCF, and I'm left with x squared minus 3 over, I can write my denominator as 2x times 3x. If you can write it as a factor of the numerator and a factor of the denominator, these values will simplify to 1, and you'll just be left with x squared minus 3 over 3x. This will be true as long as 2x doesn't equal 0. If you divide both sides by 2, you would see that as long as x does not equal 0. Now, for this particular problem, I would normally specify this, but for this particular problem, any student in intermediate algebra and beyond would be able to look at this expression here and say that the denominator can never be 0, so in this case, x can never be 0, because 3 times x cannot equal 0. So this is called an implied domain. It is already assumed that x cannot be 0 based on what you can actually see here. Usually you'll have to specify whatever you cross off cannot equal 0, but in this case it is technically implied, so you would not need to explicitly write that out. Let's see if that holds true for the next one. You want to start this problem by factoring, so see if you can pause the video and try this problem before me. So factor the numerator and factor the denominator to see if they have any common factors. Play the video when you're ready to check it. I factored the numerator and denominator and saw that x minus 3 was attached to the numerator by multiplication and the denominator by multiplication. So I was able to simplify it to x plus 5 over 3. Now, if I were looking at this domain here, it would be all real numbers. There's no way to make this denominator equal 0. So the domain of this would be all real numbers. The domain of the original was all real numbers except 3, right? If you plug in a 3 here, you'd get 3 times 3, which is 9. 9 minus 9 is 0. So 3 would cause a problem. So we want to make sure that we find all values that make x minus 3 equals 0 and remove them. So we would add 3 to both sides, and we get x cannot equal 3. So we do want to specify that x cannot equal 3. That is not assumed based on this, so we do want to explicitly write it. Last time we got x was not allowed to equal 0, which was implied, so you did not have to specify. See if you can pause the video and try part C on your own. Once you're done factoring, check your factored form with mine. Make sure you fully factor that numerator. You can see that x minus 4 is a factor of the numerator and the denominator. So your final answer in simplified form would be x times x plus 4 over x plus 2. You can write it in this form here, or you can write it in this form here. But we do want to make sure that we specify that x minus 4 is not allowed to equal 0, which implies that x is not allowed to equal 4. It is assumed that x cannot be negative 2. That is implied, so you do not have to explicitly state it. This one you would want to explicitly state, so you do have to actually write that out. This would be your final answer with this domain restriction. See if you can pause the video here and try the 4 problems on the screen. When you're ready, once you finish them, play the video to see how you did. I do have some students that struggle with factoring when they first learn the skill. If that applies to you, you can factor both the numerator and denominator on the side of your paper. So notice how I'm kind of using scrap paper here to help me factor each one individually. Then I'll put it together at the end. I like guess and check for this. You may have liked grouping. It's up to you. I like first times first equals first. Last times last equals last. I can't put a 2 here or a 4 because that would imply there's a GCF of 2, which there is not. So I'm going to try to put a 1 here, which would leave this as a 4. I would want them to multiply to a positive 4, so I know the signs must be the same. So I'm going to try both negative. 2x squared, positive 4. So this is a good guess. Let's see if it's right. Negative 8x minus 1x is negative 9x. So the middle term matches. So this is factored correctly. For this polynomial here, I would start factoring by factoring out a negative 1 from every single term. Then I would just worry about factoring that polynomial in parentheses. So x minus x plus, I want the larger term to be negative, so I'm going to put the 4 here and the 3 here. X squared minus 12, so this is a good guess. Negative 4x plus 3x is negative x. Keep that negative in front from before, just bring that straight down. And then you can put it back the way you saw it from the beginning. So this would be 2x minus 1 over x times x minus 4 over negative x minus 4 times x plus 3. All right? And we can now see that x minus 4 is a factor of the numerator and a factor of the denominator. So I'm left with 2x minus 1 over negative x plus 3. You're welcome to distribute that negative or leave it, but either way, we want to remember that x minus 4 is not allowed to equal 0. So in this case, x is not allowed to equal 4. So you can leave your final answer like this as long as you specify that x is not allowed to equal 4. We also notice that x is not allowed to equal negative 3, but again, that is implied, so we do not have to explicitly write that out. If you wrote your answer like this, this would also be full credit. For this next problem here, I just factored out a GCF, so I saw that y was the GCF on the numerator, so I was left with 3x plus y all over 2 times y. Since y is a factor of the numerator and denominator, it will simplify to 1, and you'll be left with 3x plus y all over 2. And that will be true as long as y does not equal 0. This expression is exactly the same as this expression for all values of x and y except y equaling 0. So that's why we want to write that exception right here explicitly on our paper. We want to start by factoring out the GCF here. So I noticed that both terms had a y, so I'm going to factor out a y. I was left with 4x squared minus y squared over, they both had an x and they both had a y. So I'm going to factor out an xy here. So I'm left with 2x minus y. From here, I noticed that the numerator can be factored further, so I'm going to keep going with that numerator. 4x minus y, 2x minus y, 2x plus y, all over xy. This does not factor any further, so I'm just going to leave it. 2x minus y. If there is a common factor on the numerator and denominator, it will simplify further. So I noticed that there's a common factor here. I also noticed that there's a common factor here. So I'm left with 2x plus y over just x. So this would be my expression in simplified form, but I do want to remember that y is not allowed to equal 0, and I also want to remember that 2x minus y is not allowed to equal 0. If you wanted to solve this one, you could add y. you could add y to both sides. So I could add y to both sides, and I'd realize that y is not allowed to equal 2x. So these are your two restrictions that you want to include. For part G, I notice a GCF of 2, so I'm going to factor that out right away. I get x squared plus 1xy minus 2y squared. All over, I see a GCF of 5x, and I'm left with x squared minus y squared. From here, I want to factor what's in parentheses, so I want to keep going. So I'm left with 2 times x, negative 2y, negative y. I want this combination in the middle to become positive, so I want the larger quantity to be positive. So I'm going to choose a plus for here. X squared minus 2y squared. 2xy minus 1xy is 1xy. All over 5x times x minus y, x plus y. Notice the difference of squares here. So we wanted to factor this one further as well. So now we notice that they have a common factor on the numerator and a common factor on the denominator. You can simplify that to 2 times x plus 2y over 5x times x plus y. For all values except x minus y is not allowed to equal 0. If you add y to both sides, x is not allowed to equal y. So you can leave your final answer like this, with this restriction here, or you could have written it like this. Either form is fine with me.